Hi, and welcome to another edition of Math with Mr. Douglas. Today we're looking at functions part 2, and today we're looking at f of x and g of x. T of x? There are so many x's. Yes, another edition of Math with our friends in the back who are going to be helping us out. I'm excited. Are you excited? And in the challenge section, we're looking at more things to do with quadratics. Yes, our journey to figure out what are those things and what are they made up of. All right, let's get to it. Hey, there we go. So we're talking about functions, and what I want to kind of recap from earlier was the idea of a function machine. So here is my 1920s function machine. This is the little rollers. Imagine that this is the rule. Okay, so basically you have things going through here. So the 5 goes through, and let's say 12 spits out. Well, that's pretty cool. But what happens when you put a 6 into the machine as it goes through? At the very end, 14 spits out. So what we have here is when 5 goes in, the input, we get 12. And that gives us an ordered pair. But when 6 goes in, okay, we get 14. Oh, well, that's pretty neat. Remember, we're talking about functions. We're just being really fancy and saying we're drawing a line. So you'd find where 5, 12 is, somewhere around here, and where 6, 14 is, somewhere around there. So this is what the function would look like, right, if we're going to graph it. So we've done all this before in previous videos. How would you figure out what y equals mx plus b would be? Well, first you'd go and you'd figure out what the slope is, of course. So again, this is just a little bit of a review of functions before we get into the real stuff. So if I was going to go and do that, I'm going to do this pretty fast. You go, let's make this y2. This is our y2, y1, x1, x2. So we get 14 minus 12, so that'd be 2, and then 6 over 5, so 1. So there we go. M is 1. So we're almost at y equals mx plus b. All we know is y equals m2x plus this b. So let's go and figure out what we're going to do for our b. We need to figure out what b is. So that means I'm going to go and plug in one of these points, right? So I'm going to make this my x, and this is my y. So I can put 12 here, and I put 5 there. What's 2 times 5? 10. So 12 equals 10 plus b, so b is 2. So if I asked you, again, back to this, what's the rule? What's the function in here? If I had to go and put the actual rule here, the function for this function machine is f of x, the function of x, is going to be equal to, what did we just figure out? We figured out that it was 2x plus 2. Does that make sense? And that looks horrible. Let's go and write this nicely. So the function of x is 2x plus 2. And we'll just kind of remake my little box there. Does that make sense? When 5 went in, when 5 was in our x, 2 times 5 plus 2 is 12. Yay. When 6 goes in there, 2 times 6 is 12. 12 plus 2 is 14. Yay. Okay, so functions in this example is just simply like y equals mx plus b. Not crazy, because remember, the big thing is that when we're talking about functions, f of x, make that an f, is really y. So on to today's stuff. We're going to be taking a look at functions, so the f of x, and we're going to get into just pure algebra using this kind of idea. When you're going to see functions, so f of x, so the function of x, and let's say we just had the equation x squared plus, I don't know, 3x. So that's my function. This is the rule. This is the rule. I'm just saying that. I could have written y equals x squared plus 3x. I could have written that. And I want to know what happens when I put in, I don't know, 2 into this machine. What happens when I put 2 where x is? That's all I want to know. And I want to know, what do I get from my output, which is the y. So what would happen there? Well, I would get y is equal to, and I'm going to use brackets. And I'm going to go and just put that 2 right there. So what happens? Well, 2 squared is 4. So 4 plus 6 is just 10. So the function of 2, and this is how we would say it, the function of 2 is 10. And if I was going to say as an ordered pair, it would be 2 comma 10. I can go and put in other numbers and see what would happen to the machine as well. That's the basis of our functions. Well, what if I had, other kinds of questions? Let's say I had, I don't know, f of x is 3x plus 4. Good old 3x plus 4. But now I had 2 functions. I want to know what is going to be f of 5. So what is f of 5? I also want to know what is f of x plus 1. What? What does he mean there? F of x plus 1. Okay, let's go and tackle these, shall we? Let's do the first one. What happens if the function of 5? Well, it would be to see 3 times 5 plus 4. So 15 plus 4, and that's going to be 19. Boom. So the function of 5 is 19. So if I was going to write that as an ordered pair, it would be 5 comma 19. Now this one's pretty interesting. Remember, you put this entire thing where x is. So the second one, you'd be getting 3 times x plus 1 plus 4. What happens when that happens? Well, I'm going to go and use my distributive property, use all my algebra skills. And remember, you have all the skills to go and do this. And then I still have this plus 4 here. Don't forget about that. I combine my like terms. So 3x plus 7. So the function of x plus 1 is equal to 3x plus 7. So that's functions in a nutshell. Not too bad. Let's kick it up a notch. I'm glad you asked. Let's go and do that and see what would it look like if we're going to do something called composite functions. So composite means basically combining things. So we're going to do something around composite functions. We're not going to be composting. Ha ha ha. Although composting is really good for all you environmentally friendly math students out there. Composite functions. So what is a composite function? It's basically applying one function to another. So we're applying one function to another function. So that's what we're going to be doing. So you're going to be seeing things. I'll give you the classic teacher example. You're going to be seeing f of x and g of x. Now these are just different functions. This is function f and function g. And it's all the same stuff. But we do have to be a little bit careful of what we might be talking about. So what it kind of usually looks like is, let's say we're saying the function of g through f. Let's say that. What that would look like would kind of look like this. So g of f of x. And what that ends up looking like is this, the function of g through f of x. So we want to run one function through another function. Now, if you had it a little bit different, so this is actually really important. Here's a common kid mistake. Say it went the other way. Say we put it through the function of f and then g. It would kind of look like this. So this would be the function of f of g of x. Double brackets. There we go. So it is important the order of that is being written. Now that all looks kind of like, whoa, it's a lot of just like letters and stuff and brackets. That seems a little bit confusing. Can I see some examples? Well, sure, you can see some examples, and that will really help you for composite functions. This is probably going to be the hardest kind of function stuff that you're going to be seeing thrown at you by your teachers. So here we go. If you're walking around the corner and you see a function of x is equal to negative 4x is equal to negative 4x plus 9, and around the other corner you saw the function of g of x is equal to 2x minus 7. So there's our couple of situations. I would love for you to go and find, I want you to find f of g of x. So f of g of x, which is another way of just saying it like this. So you're going to see it maybe sometimes written a couple of different ways. So sort of like that. That's what I want to find. Okay. So I'm going to, this is basically meaning you are going to go and put the g, you're going to go and put this inside the function of x. You can actually put this, you're going to take this and you're going to put it into that one. So what does that look like? So the math is really, actually, it's, this, you've been doing this for probably quite some time. It's just kind of understanding how you want to be reading it. So we have our basic stuff there, and let's go and just use our distributive property and see what happens. So we're going to go and distribute, and we get negative 8x plus 28. Don't forget about that positive 9. So we get negative 8x plus 30 plus 37. So that's what would happen there. But what if we went the other way? I'm glad you asked. What if we said find the opposite, the g of f of x? That's just fun to say. So again, it could be written this way. So now we're putting this in there. So what is going to happen with that? Well, now you would get it like that. So it really does depend on which function we're kind of putting them into. Again, I'm going to go and distribute and combine my like terms. All right, your basic kind of math principles. So it gets a little bit different, right? So it's negative 8x plus 18, still that minus 7 at the end. Combine my like terms, so negative 8x plus, I think it's 11. So those are called composite functions, putting functions within functions. Pretty cool. What, you want to see one more thing? Okay, how about an inverse function? An inverse function. Man, I tell you, you're getting such good value today. Inverse functions. Now this is definitely challenging kind of stuff. So an inverse function. So if a regular function is f of x, kind of the inverse of it, the opposite of it, is like f, this is how we kind of say it, this is the inverse function. I don't even know if I'm going to even have like my own personal math students go through this, but you know what? Why not? We're on a roll right now. I've had a cup of coffee. This is exciting. So this is called an inverse function. It's kind of cool. So let's put it into kids' terms. You basically are swapping the x's and y's, swapping the x's and y's. This is what an inverse function is. So you're swapping x's and y's, and then you're solving for y. That's basically what you're doing. Let's see an example. Just one little quick little example. So if I said I want to know the inverse of the following function. So I don't want to know this function, I want to know the inverse of it. So what does f of x mean? It means y, right? That's what it means. And I just told you I'm going to go and swap my x's and y's. And I'm going to go and solve this equation for y. So I'm going to make this say y equals, hopefully you guys can just stay with me here, negative 1 on both sides and divided by 2. So that would be, the inverse would kind of be like y equals, and there's different ways you might want to write this one. So x minus 1 all over 2. Some people might feel more comfortable writing it as y equals a half x minus 1. It's the exact same thing, but that would be the inverse of that function. Pretty cool stuff. All right, you got some really good examples of regular functions, composite functions, and even a bonus inverse functions. Are you functioning still? Let's move on, shall we? Okay, so now for challenge, we're going to be taking a look at another aspect of quadratics. One way to solve quadratics and finding out the x and the y intercepts. Here we go. Where is the green screen? I know that's what you're all wondering. Like, where's the green screen? Why did that look like an old 1920s movie screen kind of thing going on? Well, it's because my green screen failed in that clip. So I had to go old school, black and white. See what happens the next one. It's amazing when the sun changes the green screen lighting, and this weird things happen. So I thought I'd play around with filters. Who knew they were so much fun? Speaking of fun, did you see that segue what I just did there? Speaking of fun, we're gonna be taking a look at the next part of quadratics. So quadratics, and when we're looking at solving some quadratics, so a quick little kind of thing is, remember, a quadratic is a quadratic basically because it's raised to the power of 2. Okay, kind of get that out of there. And remember that we are getting those things called parabolas. Whee! And what you've already learned is you've learned what the axis of symmetry is. The axis of symmetry and the vertex. Okay, so that's what you kind of learned. Really quick review of what that would be. So for the vertex, right, the vertex little formula is negative b over 2a, and that's going to give you the x coordinate of the vertex, only the x coordinate. And then you have to go and find the y coordinate by substituting back in. So, for example, let's say you had good old y equals 2x squared plus 8x minus 5. And you want to go and replace those things in there. Remember that this is A, this is B, this is C. Did you notice that I circled the sign? Because the sign is part of it. So if I want to go negative B, so it'd be negative 8 over 2A, so that would be 2 times 2, which is going to be 4, so that would be negative 2. That's the x coordinate. I would take that, and I want to find what the y, coordinate is. So I'm going to put that right in there, like that. I love the sound effects. And I would have something like 2 times negative 2 squared plus 8 times negative 2 plus minus that 5 there. So what's going to happen here? 2 times 4 minus 16 minus 5. So let's use some order of operations. 8 minus 16 minus 5. So negative 8 minus 5 is negative 13, if my math is right. And that's going to be the y coordinate. So what is my vertex? My vertex would be negative 2 comma negative 13. I'll put it up here, negative 2 comma negative 13. So that would be that point right there. Okay, that's really, really off. Negative 2, negative 13 would be like way down here, actually, let's be honest. And that kind of parabola would probably open up, be fairly skinny. And, trick question, where's the y-intercept? Where would it cross the y? It'd cross there at negative 5. Okay, quick little review. That was a quick little review. So we're going to be talking about the pieces that you need. So when you are graphing quadratics, there are 3 things that your teacher will, 4 things? Let's say 4 things your teacher would really want. And I will show you those 4 things. I don't like that one. Let's do this one. That's cooler. Okay. So what 4 things are your teacher going to want? Your teacher is going to want this point here. This is the vertex. They're also going to want the x-intercept, and notice that there are 2 of them. I wonder why that is. Then they're also going to want the y-intercept. Right? That's what they're going to want. And then they might ask you what the axis of symmetry is, but that's just right there. But you know what? I'll label that anyways. And the axis of allies. No, the axis of symmetry. Axis of symmetry. Did anybody go and look up the axis of allies board game? It's awesome. If you like Risk, you will love axis of allies if you're really into board games. So what I'm going to show you guys, I'm going to show you this really, really cool thing called zero product property. Zero product property. The zero product property. What does it do? It basically says this. If you multiply two things together and it equals 0, one of those two things has to be 0. But do we know which one? You don't. So we have to say, well, x is either 0 or y is 0. We don't know. So we're going to use that idea for the following. We're also going to have to go back into our memories, and we're going to have to remember something about the distributive property. Distributive property, the distributive prop. So remember that's that really cool thing that did this kind of stuff. If you had A times B plus C, you got AB plus AC. And likewise, if you used FOIL, so remember FOIL, F-O-I-L, FOIL, when you had those A plus B times C plus D. Do you remember that? And you had to go and multiply everything together. And your teacher taught you something like first, outside, inside, last, or all that kind of stuff. So we're going to be using all this stuff to figure out all this stuff. Are you with me? Well, if you're still watching, you are. You still are. So we're going to go and try that. So remember, where should we start? Let's just say we had this equation. We had x squared minus 7x minus 18. And that's going to equal 0. Well, a couple things here. Your teacher wants you to go graph it. That's what your teacher wants you to go and do. We need to go and figure out the vertex first, and hopefully you can really figure that out really quickly. So the vertex, remember, is at negative b, so that's going to be negative 7 over 2a, so that's just going to be 2 times 1. So that's just 7 over 2. So that's the x coordinate. So that's the x coordinate. I'm going to put 7 halves into this because that's going to be fun. Spoiler alert, it's not going to be fun because it's fractions. What an ugly number. But, the world is full of all sorts of numbers. We can't judge numbers just because they might look different than all of us or make our lives miserable right now. I guess we could call that a life lesson. Don't judge a book by its cover. All those sorts of things. And all right, so I'm going to use my calculator because calculators are awesome. So if you hear some buttons right now, that's me using my calculator. As all good math students should always have their calculators right beside them. And I'm slowly pushing all these buttons. And minus 18. I pushed all the buttons on my calculator, and it's given me an awesome number of negative 121 over 4. That's horrible. That is absolutely an ugly kind of horrible number. So I got negative 121 over 4 as my y coordinate. Now I'm going to push this. I have a magical button on my calculator. That means it's like negative 30.25. You know what? I can live with negative 30.25 as a coordinate, and I have 7 over 2. So my actual vertex, I'm going to use a blue color to write down my vertex. I'm so excited about it. It's going to be 3.5. Yep, I just used decimals because I can graph decimals way easier. And negative 30.25. So that's my vertex. That's what I got. Woohoo! Got my vertex. The other thing your teacher is going to want you to get is your y-intercept. I'm going to use fluorescent green because that's fun. Remember, this is your y-intercept. So I want to know where it crosses that. Now, this is really easy. Don't forget that this is y. Yeah, that's y. So that's going to be really easy to do because you're just going to make x be 0. So when I do that, if x is 0, that's going to eliminate all that. And y is going to be negative 18. So this is going to be negative 18. Okay. So I got my y-intercept, that's cool. And I have my vertex, even cooler. So that's what I've got so far. I haven't even got to the actual point of today's lesson. That was like previous lessons, wasn't it? But that gets you going. But I got to know where is this thing going to cross? Because right now, if I go and use a different color. You know, this is where the vertex is. This is the y-intercept. I know it's going to open up because this is a positive number, so I'm going to get a happy face. So I know it's going to be something like that, right? That's basically what it's going to be. But your teacher doesn't want to know basically. He wants to know these 2 points because that's what teachers want. And you want to make your math teacher happy. So how are you going to do it? We're going to use that zero product property, everybody. That's right. It's time to get into math. Here we go. So zero product property. Remember, our equation was x squared minus 7x minus 18. And here we go. This is the very first thing of quadratics. You are going to think. So you're going to think a little bit. What 2 numbers multiply for c? So I need 2 numbers that multiply for c, but they add up to b. So remember, this is b, and this is c. So I'm asking you, what 2 numbers multiply to give you negative 18 that add up to negative 7? Dun, 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 dun. Now, there's lots of different ways that teachers will show you how to do this. You can go look it up on the internet. The internet's really cool. It has answers for most things. And I'm just going to say, just try and figure it out. So think of all the different possibilities. So what's negative 18 times 1? That gives me negative 18. But does negative 18 plus 1, does that add up to negative 7? Heck no. Heck no, it adds up to negative 17. So that can't work. No. Wrong. What else? How about negative 6 times 3? Well, that gives me negative 18. I'm halfway there. But what's negative 6 plus 3? That's just negative 3. Doesn't work. Wrong. So do you see where I'm going with this? And I know you're all screaming at your computers right now. It's negative 9 times 2. Maybe you're not. But maybe you are. What's negative 9 plus 2? Oh my gosh, it's negative 7. So cool. Okay, so you got your numbers. You have negative 9, and you have 2. So negative 9, and you have 2. Those are your numbers. So what you're going to do is you're going to draw 2 really pretty brackets. Boom. Like this. Remember, this is all equals 0, zero product property. And you're going to go like this. You're going to take the square root of x squared. What's the square root of x squared? X, Mr. Douglas. You put 1 there. You put another there. And then you're going to go and put one of these 2 numbers in either bracket. It doesn't matter which one you do. I'm going to put negative 9 there. And I'm going to put positive 2 there. Boom. Why did I just do that? Oh, I'm glad you asked. Let's go and use FOIL, the distributive property, to go back. I want to show you something that's going to be super magical. You're going to be like, oh my gosh, this was amazing. At the 13.5-minute mark of the challenge section, I'm going to be like blown away. I'm going to go and just FOIL this together. So I get x squared minus 9x. What else do I get? I get plus 2x minus 18. I combine my like terms. And oh my gosh, did I just get x squared minus 7x minus 18? I do. Is this the equivalent of that? Of this whole thing? Is it the equivalent? It is. And didn't I just say, if 2 things multiply to give you 0, these 2 brackets multiply to give you 0, one of them has to be 0? Did I just tell you that? I think I did. So x minus 9 and x plus 2. So x minus 9 and x plus 2 equals 0. So that means one of these brackets has to equal 0. Do you know which one equals 0? I don't. So we need to go mathematically and say either this one equals 0 or this one equals 0. So in this case, x would be 9. In this case, x would be negative 2. And didn't I just tell you that we're trying to find the intercepts? Remember we had that really crazy graph that was like down here with like 3.5? Remember this was 3.5 and this was like negative 30.25 and our y-intercept was negative 18. And I said we had to go and find this point and this point. Guess what, folks? This is negative 2 and this is 9. So now you can actually draw your parabola. So the intercepts are 9 and negative 2. You just factored to find the intercepts of a quadratic equation. Wow! That was awesome. That was absolutely fantastic. Let's just go over a couple more things with factoring. Because I think, so I'm not going to go over the entire thing. We're just going to go over some factoring stuff. So again, to get the idea. So let's say we had x squared minus 9m minus 9m plus 8. So again, what two numbers multiply to give you 8 and add up to negative 9? So instantly you just draw the brackets. Draw the brackets. Take the square root. Take the square root of this. Put one x there. Put another x there. Oh, don't forget this equals 0. Right? And then what two numbers multiply to give you 8 that add up to negative 9? Oh, how about negative 8 and negative 1? What's negative 8 plus negative 1? Negative 9. You multiply them together, you get positive 8. That's really cool. Set them to 0 and solve. So remember, you're not done. You have x minus 8 is 0, and x minus 1 is also 0. So x is going to be 8, and x is going to be 1. Those are your intercepts. So on this parabola, it would cross the x-axis at 1 and at 8. You would go and you'd also figure out the vertex and the y-intercept. The y-intercept would be 8 right there. And your vertex is probably going to be around here somewhere. And you can go and figure that out with some luck. And then you get, not some luck. You'd go use math. And you figure it out like that. Okay, there you go. Graphing quadratics using a very simple factoring way, using the zero product property and some math skills. You're set. Thanks everybody for tuning in to another edition of Math with Mr. Douglas. Hopefully you've learned something. Hey, have a chance, go and click on the subscribe button. I think it's down there. It might be over there depending on your screen. I'm not too sure. Go subscribe. We're trying to get to 100 subscribers. Yes, I know. I have big expectations. Thanks. Till next time.